So we're going to jump into the main types of examples that you need to be able to work through and do, which is all about factoring when you see a difference of two squares. Okay, so remember this section is titled Factoring a Difference of Squares. So we want to recognize each of these examples we have, A, B, C, D, and E, F, as a difference of two things that are squared. So first of all, do you recognize that this is something squared minus something else squared? Now, you might be a little bit confused because this 4 doesn't have a squared on it, but watch if we can identify this. This is 2x all squared, right? Because 2x times 2x is 4x squared, right? And you can write this as minus 5y all squared. And there, what we have is something squared minus something else squared. Therefore, it is a difference of squares. So in this case, this 2x is kind of behaving, okay? This is behaving like my a, and this is behaving like my b. So if this is a squared minus b squared, we know it's a plus b times a minus b. All right? So let's finish this one off, and we'll kind of talk about the other ones, have you do some practice on your own. So if you think about this, since you know this is something squared minus another thing squared, well, we know this factors into the sum of the two things, so 2x plus 5y times their difference, which would be 2x minus 5y, and that's it. Okay? So we took this and we factored it. 4x squared minus 25y squared is the same as 2x plus 5y times 2x minus 5y. Same idea as our warm-up. Except we went the other direction. We've already learned to multiply, but what we're doing now is we're actually going in reverse. So if I started with x squared minus 9, you could see that it's x plus 3 times x minus 3. Okay, so I want you to go ahead and do b on your own right now. So please pause and do b. Okay, let's look at this. Again, we want to identify the two pieces, the two things that are actually squared. What's behaving as my a and my b. So in this case, 36p squared is actually 6p all squared, and this is 3q all squared. So you should then have 6p plus 3q times 6p minus 3q. And that's it. Again, it's just the sum times the difference of your pieces. Now, even though these other ones look a lot harder, they're still just the same idea. If you have something squared minus something else squared, you can just break it apart into their sum times their difference, right? A squared minus b squared. It's the sum, a plus b, times their difference, a minus b. So again, what's behaving as like my a here? It's this whole thing, 2x plus 3. This one, it's actually not squared, but let's rewrite it so it is. So again, we have the first step. This one, we just leave it. But what is this squared? 4 squared is 16, and that's going to be actually x cubed, I think, isn't it, guys? Right? 4x cubed all squared is 16x to the 6th. Now we're ready to do this. Remember, it's just the sum times the difference. So it's 2x plus 3 plus 4x cubed times 2x plus 3 minus 4x cubed. Okay? So it's just the sum of the two pieces times the difference of the two pieces. Go ahead and do D, and then we'll check it together. Okay? Again, we want to write this as something squared. So you should have 3x squared squared, because that's going to give me 9x to the 4th, minus, this is already put as something squared, so we'll just leave that. And again, remember, it's just the sum times the difference of the two things. So it's going to be 3x squared plus x plus 4 times their difference, 3x squared minus. Now this is a little tricky, because if I'm subtracting all of x plus 4 here, I do want to use another set of parentheses, because it's going to be minus x minus 4 once I distribute it. So that might be a slight thing you maybe didn't write there. Okay? And then E and F are actually a little easier. We won't do too many of these like C and D. Try to understand what we did, but you really want to make sure you understand A and B really well, okay? And actually E and F are important. These are slightly simpler versions of C and D. I just use these to kind of illustrate that. So here's what I want you to do. I actually want you to do E and F on your own again now, and then we'll check the answers. Okay? So please pause now. So you'll notice 4 is 2 squared, right? So what we should have here is x plus 10 plus 2 times x plus 10 minus 2. Right? Because this 4 is 2 squared. So we have something squared minus another thing squared. So what's their sum times their difference? And actually this simplifies a little bit more. This becomes x plus 12 times x plus 8. Because plus 10 minus 2 is 8, and then plus 10 plus 2 is 12. Now, if you didn't get that one, but now you kind of understand it, you can pause again and do F. Otherwise, let's just go ahead into F. So you could realize this 25 is 5 squared, and so we have x minus 3 plus 5, right? The sum times the difference of the things being squared. And x minus 3 minus 5. Okay? So just don't forget, this piece and this piece are the same as those two pieces. It's just their sum times their difference. So then this simplifies into x minus 3 plus 5 is a plus 2, and then minus 3 minus 5 is x minus 8. So let's look at a couple more examples that are sort of like applying the thinking that we had to do in example number 1. So the first one, I'll talk through these two, and I actually want you to take a stab at them on your own. The first one, Hiroshi thinks 8n squared minus 4 equals 4n plus 2 times 4n minus 2. Whoops, I should say, is an identity. Remember, what we mean is, he thinks that this equals this always, right? Meaning, this simplifies to that, or you could say this factors into that. He made a mistake though, where is it? And then the next one here, show that this equals this is an identity. Remember, that's just another way of saying, show that this and this, if you simplify them, like equal the same thing. Now there's a couple ways of doing this, and if you think about number 1, E and F, we could actually use that process here to help answer number 3. So please do these two on your own, and then we'll do them together. Okay, so number 2 is fairly simple. Remember, one way to say it is, and you could describe this many ways, but the way I'm gonna actually start with this one. 4n plus 2 times 4n minus 2, we know that that's equal to the first thing squared minus the second thing squared, right? So that's going to be 4n all squared minus 2 squared. Now I think Hiroshi's mistake was 4 squared isn't 8. It's an accident we can easily make. 4 times 2 is 8, but 4 squared is actually 16. So he'd be correct if it was 16n squared minus 4, but not 8n squared. Okay? So I think his mistake was thinking 4 squared is 8 when it's actually 16. Now number 3. We're going to look at 2 ways actually. The long way and then the shorter way. The easy way, we'll start with the easy way, would be just look at this guy and realize that he is x plus 7 squared minus 8 squared. Because then all we got to do is say, oh, I know, this is a difference of 2 squares. So it's going to be the sum times the difference of the 2 pieces. So x plus 7 plus 8, right? And then x plus 7 minus 8. Well, 7 plus 8 is 15. And then 7 minus 8 is negative 1. So I get x plus 15 times x minus 1. And I'm done. Now, there is another way we could do this. And what it would require is that we simplify this left side and put it in normal form. you'll notice this didn't do normal form at all. So if we actually expand and simplify this, x plus 7 squared minus 64, x plus 7 squared is x squared plus 14x plus 49. And then we have minus 64. And that leaves me with x squared plus 14x, and 49 minus 64 is minus 15, I think. Now watch what happens here. If I actually multiply x plus 15 times x minus 1, if I do the distribution or use an expansion box or whatever, you're going to actually get x squared plus 15x minus 1x minus 15. And then 15x minus 1x is equal to 14x. And you'll notice that these two here are identical to each other. So we can also simplify each side separately and show that in the end they have the same normal form. They have they equal the same thing once you expand it all out. Okay? But the cool thing about this is the easier way to see this today is using this difference of two squares pattern. Actually learn how to do some calculations mentally that are pretty cool. And then we'll get to finishing off by solving equations, okay? So calculate the following mentally. Well, if you know that our rule here we're working with today is the difference of two squares is the sum of the two things times their difference, what do you notice? 80 squared minus 20 squared then must be, and again, I'm writing this out just to kind of see how to do this, but again, what goes in here? What's the sum and difference? What are the two things? Yeah, it's 80 and 20. 80 and 20. So this becomes 80 plus 20, which is 100, times 80 minus 20 is 60, and 100 times 60 is 6,000. So now what I want you to do is try to tackle B and C in your head without actually writing anything down and see if you get it correct. I'm going to do it right now too. See if you got that. 75 plus 25 is 100, and 75 minus 25 is 50. So this is going to be equal to 5,000. And again, try not to square it separately and subtract it, because squaring in your head is a lot of work, but the numbers that we're using here turn out to be nice. Now see. You should have 7,400, because 87 plus 13 is 100, and 87 minus 13 is 74. And 100 times 74 is 7,400, 7,400. Okay, last one. Solving the equations by factoring and the ZPP. Remember, that means break it apart and apply the zero product property. Now, one quick thing for you guys. We have learned before with this that if we add 16, and you can write this down as a separate way to do it, okay? If you add 16 to both sides, you get x squared equals 16, and then you can kind of think in your heads, well, we know that x could be 4, but it also could be negative 4, because both of those numbers can square to make 16. That is definitely one way that's totally acceptable to do it, and it'll actually be helpful later on in another lesson. So you should keep mental note that you can still add over the other side and then take a square root. Really what we did is we did a square root here, but okay. But we're also going to see that we can get those two solutions by applying our rule. X squared minus 16 is x plus 4 times x minus 4. Okay, that's just directly applying our thing, our property. And this gives me negative 4 or positive 4 as my two solutions. So why don't you go ahead and take a stab at B and C, and then we'll do D together, and you can do E and F on your own also. Okay, so x plus 7 times x minus 7, because x squared minus 49 factors into x plus 7 times x minus 7. Therefore, we get x equals 7 or negative 7 or 7. Those are my two solutions. For this one, it may be one that you like want to do in your, in your head a little bit or whatever, but but if we actually break this apart, we should get 2p plus 10 times 2p minus 10, right? Because this is 2p squared and this is 10 squared. So my pieces are 2p and 10. Therefore, let's see, if 2p plus 10 equals 0, then p should be negative 5, or p could be positive 5. Okay, so those are the two numbers for p that make this piece 0 or that piece equal 0. Now let's do d together. Hopefully you recognize right now, because we did the work ahead of time, so it'll save us a little bit of time, we actually already learned how to factor this. We already did this example, we just haven't solved it as an equation. So if you think back, this one I think we did in number 1, but D, E, and F we did in either number 1 or number 2. We've done each of these together. And we actually already talked about how they fully break apart. So this one became x plus 10 plus 2, x plus 10 minus 2, but now we're saying times that equals 0, and x plus 12, x plus 8 equals 0. So either x equals negative 12 or negative 8. So those are our two solutions there. Now that you've done this, please do E and F on your own, and we'll just quickly check the answers, and that's it for our lesson today. Don't forget to look back in your notes at E and F, how we broke them apart, because then that saves you a lot of time. Okay? So I'll skip the first step, actually. It's going to be x minus 3 plus 5, so it's going to actually be x plus 2. And again, we already did this. And x minus 3 minus 5 times x minus 8 equals 0. Okay? Because that is the same as that. And therefore, x equals negative 2 or positive 8. And this last one we did as well. And this worked out to be x plus 15 times x minus 1 equals 0. And I got x, that means x must be equal negative 15 or positive 1. And there's our two solutions. So with that, I think we've covered everything we need to. Happy math again, and good luck with this lesson.